Multiparadigm Data Science with the Wolfram language. Section 1, the project workflow. We are now at the third stage of the project workflow, that is explore. We'll try some exploratory data analysis for our example project where we downloaded the tweets made by Wolfram Research and are hoping to use them to derive some data-driven insights. Exploratory data analysis is all about trying to gain an intuitive understanding of the data. We don't have to know exactly what sort of algorithm or technique we want to employ for the data yet. In fact, with the multi-paradigm workflow, we are encouraged to keep an open mind and try out different techniques. There is no wrong choice at this point, and this makes it much more fun. As the exploration proceeds, we may even find ourselves reframing the questions we started out with. Let's explore the Twitter data and figure out if it can be used to answer questions like how many tweets were made, what were the tweets talking about, who were featured in these tweets, and so on. Now, to answer the question how many tweets were sent out, we can look at the date histogram showing the number of tweets by year. We can recreate the same date histogram, but this time binning the tweets by the day of the week on which they were created. This shows that the majority of the tweets went out on Wednesday. In another version of the histogram, we can bin the tweets by hour of the day. We see most of the tweets were made during regular business hours. But someone was burning the midnight oil at these tail ends. While we are exploring the numbers, it would be nice to know how many tweets were liked or retweeted a certain number of times. So here's a histogram of the number of times a tweet was liked. We see that the majority of the tweets were liked anywhere between 0 and 25 times, while when we look at the retweets in the same way, we see very few tweets were retweeted more than 400 times. We can actually pull out these tail end tweets, liked or retweeted more than a certain number of times, and look at their text and hashtags. Now that we've explored the numbers a bit, let's explore the actual content of these tweets. We can look at the hashtags in the tweets to see what Wolfram Research has been tweeting about. A plain list is not very useful, so maybe we could count and sort the hashtags in descending order of number of times they were used. But the same information becomes more appealing visually in a word cloud, and seems like this would be a good way to convey the importance given to certain hashtags or specific topics in the tweets. Here is a word cloud made out of the raw text from the tweets, and it is immediately visible that the text needs some cleaning. There, much better once we use the clean text function we developed before. In addition to the hashtags and user mentions, a few other interesting words pop up. It appears that we announce a lot of new things, and we are also very polite as we say a lot of thanks, and we also encourage people to learn. Next, let's explore to see who were the people in the tweets. We did look at the users mentioned in the tweets. We can create a word cloud with that information and can see who was mentioned most often. Well, no surprise there. We have the Twitter handles of these users, but we could get more information if we could download the user data. So back to the data wrangling stage to download and organize some more data for these users. You'll notice a few errors while we try to download the data because not all accounts make the information publicly downloadable. But for the ones that are successfully downloaded, let's see what is available. We have the user ID, screen name, or the Twitter handle, display name, locations, favorites count, and friends counts. Notice there is no consistency in the way location information is provided. Sometimes we have the city and state, or just the city, or just the country, or nothing at all. Now, a little data cleaning can get us from these place names in natural language to actual geographic coordinates. And for that, we can use the computed location interpreter in the Wolfram language. It easily converts the text from natural language to usable geographic coordinates that can be plotted on a map. In fact, with a geohistogram, we can see the density of the users on a world map, which provides some indication of regions where most of these users who are mentioned in the Wolfram tweets are located. We had seen in the earlier word clouds what the Wolfram research tweets were talking about. It would be interesting to see what the tweets by all these users who are being mentioned by Wolfram research, what are they talking about? So back to data wrangling again to download the hashtags used by these users and laying them out in a word cloud. We see shared interest in AI, machine learning, data science, blockchain, and of course Wolfram language and Mathematica. In case you're wondering, Shambana here is how folks refer to the twin cities of Champaign Urbana, Champaign being the location of Wolfram's corporate headquarters. Branching out into a different path of exploration, we can try to look at the social network of these users, who is being mentioned by whom, and how they are connected through such user mentions. First, let's download the people who are mentioned in the tweets made by all these other people in our list. Some people do not mention others, so their list is empty. If we draw an edge from one user to another every time the former mentions the latter, we can create the network of users mentioning each other. So let's shortlist the people for whom the right hand side is not an empty list, that is, people who mention at least one other person in their tweets, and create a list of edges going out from each node in our prospective graph. A whole bunch of edges will connect Wolfram research to people in our list. Now, this is the graph showing all the connections. It has over 13,000 vertices and 16,000 edges. So let's try to focus on a simpler subgraph. For every user mentioned, the node representing that user has an edge coming into the node. These edges make up the in degree of the node. The most popular person in the network, most mentioned by others, would have the highest in degree. We pick the vertices with in degree above a threshold, choosing people mentioned at least a certain number of times in this network, and attempt to visualize the simpler subgraph. This picture is much clearer, but we could probably scale the vertex size according to the in degrees so that we can at once see which are the more popular nodes. Exploratory analysis can be the most fun part of your project, so sometimes you just have to put the brakes on exploration before you get carried off with the fun and ease of doing such analysis. We've tried a bunch of things, and now we have some ideas about the type of insights we might be able to draw from the data. We also came up with some new questions that can be asked, and also additional data that can be used to augment the data we started out with. Armed with these thoughts, we can move on to the analysis phase of the workflow.